lecture, we start chapter 3, loops and selection statements. First off, I would like to go over a few review questions. These are all multiple choice questions just to summarize the main points we discussed before. So I would suggest that you pause the video, read the question and think about your answer, and then listen to my discussion afterwards. So here the question is, which of the following outputs data in a Python program? The input statement, the assignment statement, the print statement, or the main function? Well, we didn't discuss the main function before, so now we have three options. The input statement, we use this when we want to ask the user to input a data for us. So for sure, we don't use input statement to show the results. So the right answer here is the print statement. If you remember, we always use print statement to show the value of variables and the results of the code. The next question is, what is the set of rules for forming sentences in a programming language? Semantic, pragmatics, syntax, or logic? Semantic is the study of relationship between words and how we draw meaning from those words. But if you remember, we discussed the definition of syntax, which is a set of rules for forming sentences in a programming language. So each programming language has its own syntax. So the right answer is C. The last question is, what must a programmer use to test a program? All possible sets of legitimate inputs, all possible sets of inputs, all single sets of legitimate input, or a reasonable set of legitimate inputs. First off, we test a program for legitimate inputs. For example, if it only takes positive numbers, we are not going to test it with negative numbers. Okay. But it's also possible that a piece of program accepts all integer numbers. So we will have an infinite number of options. And it's just not possible to test all possible options. So the right answer here is a reasonable set of legitimate inputs. We want to make sure that the algorithm is working properly, and we test it with a reasonable sets. Sometimes it's just not possible to test all inputs. With that, we start chapter 3. In chapter 3, we learn how to write a loop to repeat a sequence of actions. Sometimes we want to repeat an action 3 times, 4 times, or 100 times. In those cases, we use a loop. We also learn about a loop that counts down and up using variables. So variables can get different values, and we use the variable to write a for loop that counts down and up, and we will see a few examples. We also discuss a loop that holds when a condition becomes false. It means that in each iteration, we check the condition. If we meet the condition, we continue. Otherwise, we stop. We will also discuss selection statement to make choices in a program. We need to check a few conditions, and if that's true, we do this procedure. If it's not true, we do another procedure. Repetition statements or loops repeat an action. Now, we have two types of loops. Those that repeat actions a predefined number of times. We call it definite iteration. So we know that we want to repeat this piece of code 10 times, 100 times, or 1,000 times. So we know how many times we want to repeat it beforehand. That's what we call definite iterations. Another types of loops perform action until program determines it needs to stop. So there is a termination condition, and we call it an indefinite iteration. So we don't know how many times exactly, but in each iteration we check that condition. Python's for loop is the control statement that most easily supports definite iteration. Here you see the first piece of code for a for loop. For L in range 4, print this statement. So we want to print this statement 4 times, and we use the range function. So I will discuss this range function in a few minutes. But overall range function generates a sequence of items starting from 0. So range 4 means that, okay, repeat this statement 4 times. And here you can see the form of this type of loop. After 4, we expect a variable, and you can go with an arbitrary variable. In this example, it was L, but you can go with test, we can go with I, J, K. So for variable in range, and then the number, how many times you want to repeat this. If it is 10 times, then it would be in range 10. Colon, then you have several statements. So the first line of code is sometimes called loop header. Rest of code is loop body and must be indented and aligned in the same column. So you are going to see if it is not indented, then you will get syntax error. Okay, now let's try to run the first for loop here and pay attention to the color. For L in range 4, then colon, print, it's alive. When you run this, you will see that syntax error. You fix it, and now we printed the statement 4 times. 4 in and range are reserved words, so the color is green. And with print, we just show this, display this statement. Okay. Don't forget this colon after the for statement, otherwise you will get a syntax error. So here's our first example for the for loop. Loop to compute an exponentiation for a non-negative exponent. So we want to calculate 2 raised to 3. It means that 2 times 2 times 2, 3 times. So we can use for loop because we know how many times we want to multiply that number. So in this piece of code, you will see 3 variables: number, exponent, and product. And remember, we always initialize variables. Now we will see the for loop. For L in range exponent, product is equal to product times number. And then we print the result. Let's try to run this piece of code. The first variable, number equal to 2, exponent equal to 3. We can change the values. And product equal to 1. Then we have our for loop for L in range exponent, then colon, product is equal to product times number. And then we want to show the result, print product. When you run this, you will see 8. 2 raised to 3 is equal to 8. Now we can test for other values. 2 raised to 4, then it's equal to 16. We can also test when exponent is equal to 0. We know that 2 raised to 0 is equal to 1. So let's see if this algorithm can return 1. So we test with a few input parameters, and then we look at the results and see if the algorithm is working properly. So we use a for loop to calculate an exponentiation for a non-negative exponent. So here's another example, a loop that counts through a range of numbers. So this piece of code has 4 lines of code. It looks pretty straightforward, but we would like to know what a mathematical function is related to this piece of code. To do that, we use algorithm trace technique. Algorithm trace is a technique to manually verify that an algorithm is working properly and also understand the logic. So to do that, for each iteration, we update the values for variables. So for round 1, product is equal to 1. So we have two main variables here, product and count. So product is 1 here, and then we have a count which takes values in range 4. By default, it starts from 0, 1, 2, 3. So we repeat this 4 times. So in first iteration, product is equal to 1 times count, which is 0 plus 1. So 1 times 1 is equal to 1. This is the end of the first iteration or first round. In second round, product is equal to 1 times count. Now count takes 1, 1 plus 1. So 2 times 1 is equal to 2. This is at the end of the second iteration. Third round, product is equal to 2 times. Now the new value for count is 2. I'm choosing from this set over here. 2 plus 1. So it's 3 times 2 equal to 6. This is the end of the third round. And the last iteration, product is equal to 6 times 3 plus 1 equal to 24. So this piece of code technically calculates 4 factorial, which is equal to 4 times 3 times 2 times 1, 24. So we manually check the output for each round, and then we put it together. We realize that, okay, it's the factorial of a positive number. So you can change the range. For example, if you want to calculate 5 factorial, then you update for count in range 5, and then you will see the result for 5 factorial. So about range function. So for for loops, we typically use range function because we know how many times we want to repeat that action. Range returns a list, and list is one of the data structures that we are going to discuss in the next lecture. So for now, consider list as a sequence of items. It can be numbers, it can be strings. So list range 4 produces a list of or a sequence of numbers, and by default it starts from 0 through 3. It never reaches to 4. Okay. Now if you want to change the starting value, the default value is 0, but let's say we want the number start from 1, then you have range 1, comma 5. So it starts from 1 all the way through 4. Again, it repeats the action 4 times, but the starting value is different. Range can expect a third argument that allows you to specify a step value as well. So if there are 2 examples here, range 1, comma 6, 1. So it starts from 0 all the way through 6, and the increment is 1. So the result would be 1, 2, 3, 4, 5. But if you want to change the step, so you change the step to 2, then the output looks like this, 1, 3, 5. So the increment is 5. So 3 arguments can be passed to a range function. We also have augmented assignments. With assignment, we can assign values to variables, for example, a equal to 17 or s equal to high, which is a string. The assignment symbol can be combined with the arithmetic and concatenation operators to provide augmented assignment operations. Many coders use augmented assignment. It's a short version. Here you can see several examples. A plus equal sign 3. It's equivalent to A equal to A plus 3. So it's shorter, and we usually use augmented assignments. Or A minus equal 3. It's equivalent to A equal to A minus 3. And if you want to combine two strings, then you use S plus equal sign, and then there. So S was equal to high, and then the result would be high there. So you can see the general format here, variable, operator, equal sign, and expression. So that was a note on augmented assignment. Now we can move on to selection statements, if and if-else statement. Overall, selection statements allow a computer to make choices based on a condition. For example, if A is equal to 3, do this. If A is not equal to 3, then do this. So here in this table, you can see the comparison operator and their meaning. 2 equals sign means equal. Exclamation mark equal sign means not equal. So if you want to say if A is not equal to 3, then you use the exclamation mark. Then you have less than, greater than, less than or equal, or greater than or equal signs here. Now let's start with the two-way selection statement. So if this condition holds, do this, otherwise do the rest. So we call it a two-way selection statement. We usually use two-way selection statements to check inputs for errors. In this piece of code, we are using math module that we discussed before, the very first module that we played with. So we first import it, and then we ask the user to enter the area of a circle. So this piece of code asks the area of a circle and then returns the radius of that circle. If area is a positive number, then radius is equal to math.sqrt. So we are calling the square root. Sqrt is the function defined under math module. So calculate this square root of area divided by the pi value, and then print the radius is this value. Otherwise, print this message that the area must be a positive number. So if the user enters a negative number, then we give that error, and then we guide the user, and then they can use that piece of algorithm properly. Okay. Let's try run this code in a notebook file. Here. Import math, area, float, input. With input statement, we ask user to input a value, and then the data structure is float, so it can be a fractional value. It's assigned to a variable named area. Now, if area is greater than 0, then colon, radius is equal to this number, and then we print this number. The radius is this value. Else, print the error message. So this is a two-way statement. We have if and else. And if you run it, okay, enter the area, let's say 4.5, and then it displays the result. The radius is 1.196. So that's how you can guide users to input right numbers for your program. But overall, the syntax for if and if-else statement, you start with if colon, and then the sequence of a statement, then else colon, the sequence of a statement. So here's an example, multi-way if. What if we have several conditions to check? In this example, we want to find the letter grade based on the range of numeric grades. If it's above 89, then it's A. If it's between 79 and below 90, then it's a B. So here we have 4 conditions. We call this multi-way if statement. We start with if, condition colon, and then we have a sequence of a statement. Then the second condition we use elif. Elif colon, then the sequence of a statement, and at the end for the very last condition we have else. So here we are adding elif. If, elif, else. And you are going to see that in an example. So let's write a program that determines and prints the letter grade corresponding to an input numeric grade. So we ask the user to input the number, the grade, and then we want to return its corresponding letter grade. Now let's try to write this piece of code here. I use comments, request input. So we are going to use the input a statement assigned to a variable named number. My data structure is integer, or it can be float. If fractional values are allowed. And then a statement or a sentence for the user. Enter the numeric grade. And then we want to determine the results and display it. So I'm using comments just to communicate with other coders or with the user. Now here we have the conditions. If number is greater than 89, colon, then a new variable called letter is equal to A. Now elif number greater than 79, colon, then letter is equal to B. Another elif number is greater than 69, then letter is equal to C. Otherwise it's F. So then I have the else colon letter is equal to F. At the end we want to print this statement. The letter grade is comma the value for letter. Okay, let's run this. So enter the numeric grade. I would go with 91, and then the letter grade is an A. Let's try other inputs. Let's go with 78, for example. The letter grade is C. Can go with 50, for example, and then the letter grade is F. So it seems that the algorithm is working properly, checks different conditions, and based on that it returns the letter grade. Another example, just to play with selection statements. Let's write a program that accepts the lengths of 3 sides of a triangle as inputs. Okay, so we will have 3 inputs and each represent the length of a side. Now the program output should indicate whether or not the triangle is equilateral. So if they have identical lengths, the triangle is equilateral, otherwise it's not. Okay, so we have a condition to check. Let's try to code this. So again, I start with a comment, which is request input from the user. So I need 3 input, let's say side 1, side 2, and side 3. So we will have 3 input statements. The data structure integer, I choose integer, then input, then I ask the user to enter the first side. Another variable, side 2, the same line of code, but enter the second side. And then side 3, enter the third side. So now we assign values to each variables. Next step is determine the results and display it, right? Check the condition. Okay. So there is one condition here. If side 1 is equal, remember we use 2 equal sign, equal to side 2, and side 2 equal to side 3, colon, print the triangle is equilateral. So if this condition holds, then the triangle is equilateral. Else, so this is a two-way condition. Print this statement. The triangle is not equilateral. Okay. Let's run this. So enter the first side, I go with 12. The second side 12, the third side 12. Now the triangle is equilateral. Let's try another set of inputs, 12, 23, and 12. Then the triangle is not equilateral. So it checks the condition and the results are shown here. So remember when we in if statement, when we want to check the equality, then we use 2 equal sign. And also here I use a Boolean variable. If this statement and this statement, it means that both statements should be right. And I will discuss the Boolean statement in a minute as well. Okay, so we wrote the program here, and it could determine whether or not the triangle is equilateral. So here's just a quick reminder on Boolean expressions. A is equal to true, B is equal to false. A and B returns false. So when we use the AND statement in this table, you can see the result. A and B, A or B, and A not A. So let's just quickly run this in Python so you can see. A is equal to true, the color is green. B is equal to false. And now we want to see A and B. Let's run this. You can see A and B is false. So far we discussed the for loop. Now we want to discuss the while loop. The while loop can be used to describe conditional iterations. Conditional iteration requires that condition be tested within loop to determine if it should continue. So it's called continuation condition. Here you can see the syntax, while, and then it expects a condition, colon, and then you have a sequence of statements. So when we use while loop, we don't have to determine the number of iterations, we just have that condition. But improper use may lead to infinite loop. It means that your program never stops. Condition is tested at top of the loop, and a statement within loop can execute 0 or more times. So that's the risk of using while loop, and we should be careful. that we have a termination criteria. Here, you can see an example with a for loop and with a while loop. We use a while loop for a count control loop here, and we have the summation. So summations in this range 1 through 100,000. So 1 plus 2 plus 3 plus 4 all the way through 100,000. So we can do that with the for loop or with a while loop, and you can see both versions here. So let's look at this codes in the Python, the Jupyter notebook, the summation with a for loop. Okay. So we use a variable, we initialize it, the sum equal to 0, and then for count in this range, starting from 1 all the way through 100,000. Now in this line you can see augmented assignment, the sum plus equal count. So it equivalents to the sum equal to the sum plus count. And then we do this 100,000 times. And at the end we print the results. Okay, let's run this. And this is the result. So 1 plus 2 plus 3 all the way through 100,000, it's equal to this number. Now we can code this using a while loop. So in the while loop version, you see two variables, the sum equal to 0 and a count variable, which needs to be initialized. While then we have the condition. While count is less than or equal to 100,000, then we have the augmented assignment, and we add count by 1. So count equal to count plus 1. So we update the value for count, and then it goes to the top of the loop, check this condition, and then runs the statement under the while loop. It updates the value for count, it goes to the condition, and if the condition holds, then it runs this code. Okay, if we run this, we should get the same results. And you can see that the result is the same. So for a problem, we can use either a for loop or a while loop. Sometimes, because it's your preference, but there are cases that we really don't know that how many times we want to repeat the action. In those cases, we go with the while loop and with a termination condition here. And pay attention here, if you don't update the count variable, its value, then it's always true, because then count is equal to 1 and it's always less than this number, and you will have infinite loop, it never stops. So that's how we make sure that we have that termination condition. Okay. You have both pieces of codes in this slide. Now, that being said, let's look at this review quiz. Consider the following code segment. How many iterations does this loop perform? Okay, we have a variable, the sum, and then we have while true. So this condition means that it's always true, right? While true, then calculate number. Number asks the user to enter a number. If the number is not empty, the sum is equal to this number. So we will have an augmented assignment. The sum equal to the previous value plus the number. So you can keep continuing this until the user enter nothing. So it's empty. If the number is equal to empty, then break. It means that now you leave the while loop. Now the question is, how many iteration does this loop perform? Okay, we look at the best case scenario. So we ask the user to enter a number, and the user doesn't enter anything, just a space, press enter, then it breaks. It means that nothing, so it just out of the while loop. So in this case, there is just one iteration. And now if the user keeps entering a number, then it calculates that number and then asks the user to enter another number, and it keeps going until the user enter nothing, and then we have the break statement. So the right answer here is at least one. For the first iteration, it's nothing, then it breaks, and then it continues until the user press a space or enter nothing. So if we don't have this break statement, it would be an infinite loop. So it never stops without this break, because this condition that you have here while true is always true. So with this break statement, you make sure that at some point you leave this while loop. Now the main point in this lecture. So we discussed control statement, which determine order in which other statements are executed in program. So with conditional statement, if and else statement, we just define the order for different procedures. Definite iteration is process of executing set of statements fixed predictable number of times, and in those cases we use a for loop. So we want to repeat this 100 times and we know it beforehand. For loop consists of header and set of statements called body. It can be used to implement a count control loop, and we had a few examples. We also use range to generate sequence of numbers. Boolean expressions evaluate to true or false, constructed using logical operators and or not. And we had one slide just to remind you about Boolean expressions. Selection statements enable program to make choices, and sometimes we use the selection statement for handling errors. So this is the very last slide for this lecture. Next time we will discuss list as a data structure in Python.